Welcome to today's webinar. The topic today is most frequently asked questions answered by Dlubal's support team. I answer questions that we get from a lot of users from our programs. I'm Andreas Hörold. I'm responsible for marketing and public relations in the Dlubal Software company. For instance, the webinars, Dlubal website, customer projects, and so on. And I will present the webinar. We will provide these kind of webinars monthly with the most frequently asked questions. Okay, my two colleagues can introduce themselves.
Okay. Hi, my name is Caroline Lessmann. I work here at Dlubal Software in the marketing department, so I'm responsible for the webinars and newsletter as well, and I'll answer your questions today.
Hello, my name is Markus Baumgartel. I am responsible for customer support and frequently asked questions on our website. And today I will help my colleagues to answer your questions during this webinar. Thanks.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. You can ask questions via the control panel on the right side of your screen. You can enter a question here and my colleagues will answer you. If you don't get an answer during the webinar, because there are too many, you will get an email after the webinar. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, then let's turn to the program. That's the first model, and the first question is, how can I quickly model a bolt connection in RFEM? The aim is to consider the force transmission of a bolt in an opening as realistically as possible. Now, there are two options that I would like to show you. First option is using a spoked wheel, like a wheel of a bicycle, to transfer the load from the bolt to the surface. And the other option is to use a surface with the stiffness type without membrane tension. So we start with this bolt here. If I use the solid model, it looks like the bolt is connected with the surface. But if I click here right above to the wireframe model, you can see the bolt isn't connected with the surface here. I created that ring here also on this side. To have got a better FE mesh, I can show you. I calculate or generate the FE mesh. And that looks better with this FE mesh when we have such a ring here. Okay, let's start with the first spoke. Here, left above, I used the option New Single Member. I use a rigid member. I could also use a beam, but then I would have to create the cross section. The cross section had a weight and so on. The rigid is better in that case. Okay, then I have to consider hinges and nonlinearities. So then dialogues here added, hinges, nonlinearity, and a section is not necessary, as I said. Hinges at the member end, we add hinges. So with the option hinges in Y direction, in Z direction, you can see that here in the preview image, in Y and Z direction, and around the y-axis. Okay, that's all for the hinge. Then we have to add the nonlinearity. I create a new nonlinearity. Yeah, the first type is failure under tension, or failure if tension. We will use that, but as you can see, there are different options. For example, slippage, tearing, yielding, and so on. I will use failure if tension. We would like to transfer only compression with that member, not tension. Okay. Okay. So from the middle to the edge. Okay. So the first spoke is created. I copy that with pressing the Control key. You can see the plus on the mouse, I hope. And then I use the drag and drop function and copy it on the other side. Then I select both. So, and then right above, I use that feature here, rotate selected objects. I have to create copies, and I divide the circle, the 360 degrees, in 36 parts. That's why I use here 10 degrees as a rotation angle, and I have to enter here 35 number of steps. Okay, then I have to rotate around axis X. You can see that here, that's the X direction, and I have to select the middle of the circle as point P. Okay, so, and all spokes are created. So then the next step is to create a nodal support, or two nodal supports. So in support in X direction and in Z direction. And I define around axis X a small spring constant that the bolt can't be rotated. Okay. Okay. This point and this point. Okay. That's the first option. And for the other hole, we use the second option. So here left the both, I use the function new surface, and I would like to select the boundary. So the stiffness type should be without membrane tension, as I mentioned already. Now, as thickness, I use 60 millimeters, and I use the same material as for the other surfaces. So, okay. So, and I have to select the boundary lines. So I change to the transparent model, and you can see the new surface with the stiffness type without membrane tension. So then we can calculate all. So then we've got the results. I select surfaces and the NY internal forces. Y direction is this one. And you can see here, or I select only the bolt. Okay. I think then it's quite good to see that we have got only compression in that surface, because the stiffness type is without membrane tension. Only compression is transferred. So I cancel the visibility mode. So, and then let's take a look at the spokes. I would like to show the internal forces for the members and the normal forces. So for that kind of member, I have to select here under members the results on couplings. Okay, and as you can see, we've got only compression in the spokes, no tension on this side. Sorry, have to rotate it. So I think it's quite good to see. Okay, that should be all for this model. You could see two options to model such a bolt and calculate it. Okay, then we come to we turn to the next question. What happens with my model when RFEM or RSTAB crashes? In case of crash, RFEM automatically creates a backup file, and the file is not directly available to the user, but can be restored when restart the program. You've got also options here under options, program options for the automatic saving. If you select that here, automatic save to backup copy, you can define in a interval for the saving, and you can also save after every calculation that you don't lose results after a crash, etc. So, and I go to the Internet Explorer, to the Windows Explorer, sorry, and you can see the backup file, BAK. And in case of a crash, you can rename that, for example, in board 1 and delete BAK, and then you have the backup file, the saved file. Okay. That's all to this question. Next question is, what happens to the online license when a computer is broken or stolen? I can open here right above the license manager. You can see now which license I got. Almost all available add-ons are, I can use them. So, and if you click here, you can open the product details, or if you want to buy a product, you can be forwarded directly to the web shop. So, the license is transferred to the user's computer when logging in and remains there until the license is returned, the program is closed, the rent period has expired, or the effective time has expired in the event of crash. If I click on the calendar here, you can see there's a rent up time. In the case of the computer is stolen or broken, the license is blocked for 1 day. That's the default setting, but the rent time can be extended to 30 days. You can extend it, for example, to this day, and you can see here borrowed until the 3rd September. The disadvantage is if the computer is broken or stolen in that time, you can't work on a new computer with your online license. That's why we've got this default setting. So Okay, that's all to this question. I turn to the next model and the next question. The question is, how can I adjust font sizes in RFEM 6 and RSTAB 9 for a screen view and a printout report? Now we have got different entries separately for printout report and display properties. You can see that when you open the display properties by right click or under options and display properties. For example, if you would like to increase the size of the values here, you can search it in results and deformations, and you can see the different colors here and the font. You can move it a little bit on the left side, and then I can edit it for the screen. For example, in a larger number and bold. Okay, and if I click apply, take a look at the values, and now they are increased. You can save templates for such settings, or you can then you can load templates. Two templates are already available. One for the dark background. I can do it, apply. And now we have got a dark background. And we can load the white background again. Now we have got the standard settings again. Okay. Yeah, that should be all. You could also define larger sizes for the support values and so on. Yeah, it's the same workflow. Then we come to return to the next question. Where can I find the cross-section classification in RFEM 6? The style design add-on for RFEM 6 performs at each design location a detailed cross-section classification before the design. And for each design, the cross-section classification is saved in the details, design details. I would like to show you where I can find that. I select here style design in the table. And for example, on this point here, this main beam here, you can double click or press design check details. And now you can find the section classification here. So the classification, class 2, and can see class 1 for the upper flange, the other upper flange. Then that's the web. Both sides are supported, and the lower flanges. Also means here you can find the section classification, and also the whole details, the equations from the standard, and so on. Okay, that's all. Then we turn to the next model and the next question. A quite simple model, and the question is, my results of the calculation with the add-on torsional warping with 7 degrees of freedom are implausible. What could be the reason? There can be different reasons for results that are not plausible. You have to, for example, to check the boundary conditions. This includes, for example, the selected load application. You can check the transverse stiffness and the transitions between the members. If I click on the member, you can see transverse stiffness are defined here. Let's take a look at them. You can see on that side there's a very small stiffener. We could decrease it. So now you can see this side. This end plate is quite okay. So let's increase the stiffener on that side. 80 and 180, and that should be quite okay. So, then you can also check the design types. Effective lengths are not necessary for the warping torsion analysis, but you can, for example, check the design configurations with pressing that button here. Edit ultimate configurations. For example, if you have checked on or off to perform the stability design, the use of the gamma M and so on. Okay. Then you can also, that is quite okay. The sections, you can check the sections. For example, this one. It could be that the warping stiffness is deactivated. That can be occur different results or implausible results. Okay, I repeat the question. My model is unstable. How can I fix that? Let's calculate it, the model. Okay, that looks much better. And we get an error message. There's something wrong. So let's take a look at the model. On the first view, I can't see anything what's wrong. But when I go to the wireframe model, I can see that members here, those are couplings where are too much hinges. And that should be the reason, but we can check that. I select in the base data or activate the add-on structure stability. Okay. And I go to the load case and activate the calculation of the critical load with the structure stability add-on. So I can define different settings here. And that what I mean is calculate without loading for instability check by mode shape. The program calculates the structure without load, and we can see in mode shape. So then calculate. You can see here stability analysis, and we can see what's the problem with the mode shape. So we will correct it. So I select this node and this node, then right click, delete node and merge joint lines, or in that case, members. Okay. Then I can deactivate the structure stability add-on, calculate it again. Yeah, and now all should be okay. Yeah, that's a good way to find such model issues or mistakes. Okay, then the last questions. How can I create the printout report header and create templates? Yeah, left above, I select a new printout report. I open a new printout report, and then left above, left at the bottom, you can see the print setup, and you can, for example, define the lines here, first line, second line, for the address of your company, for example, and also different options that you can define here. So, for example, I enter here Dlubal Software GmbH, then only 3 lines. Selvig 2 and Tiefenbach. You could also add the telephone number and so on. And you can see in the preview that the address is defined. So, and then you can save it as a template, and later on you can read the template or import the template. You can see the button here, left at the bottom, load from template, where are different templates already available and your saved templates. Okay, that should be all for this webinar. I would like to show you where you can find the recording of the webinar. I turn to our website, dlubal.com/en, and under news and events, you find our webinars. That's the webinar of the next week, model and design timber structures. Maybe you've got already an invitation. So, and that is the one from today, 4th August. And in the next days, you will find the recording here and already the models here. Yeah, and if you don't have got our program, RFEM 6 or RSTAB 9, you can download the full trial version here. That's those are for free. The RFEM 6 trial and RSTAB 9 trial. You can use it or use them for 90 days for free. Now there's also our section and our wind that you can download. Okay, that should be all for today's webinar. Yeah, I hope you enjoyed it. I thank you for your attention. Thank you to my 2 colleagues for answering the questions. Maybe last information: when you close the webinar, there's a short survey. You can answer some questions. It takes only, I think, 1 minute. Would be very nice. It's quite important to our quality management. Just note that the worst score is 1 and the best score is 5. Okay, I wish all a nice rest of the day and bye-bye.